Theories explaining the construction of the Great Pyramid usually default to esoteric technology or undocumented armies of slave labor. Both suffer from an operational deficit, a lack of verifiable evidence bridging the gap between architectural vision and the physical labor required to achieve it. The physical reality requires moving roughly 2.3 million stones and stacking them to a height of 481 feet. We can see the finished architectural state, but there is a disparity between the completed monument and the lack of historical documentation showing how these materials were maneuvered into place. The final product is obvious, but the mechanical process remains missing. Uncovering the truth of the ancient world requires us to look past the grand spectacle and audit the overlooked mundane operational details. The most common mainstream hypothesis for moving these blocks into the sky is the massive external ramp. Engineering stress analysis reveals the physical bottleneck of this theory. A ramp built at a shallow enough incline to reach the apex would require more material than the pyramid itself, hitting volume constraints and structural failure points before the project could ever be finished. Because the math behind external ramps fails, investigators are forced to search for an internal mechanical solution. Without a verified mechanism to hoist stones weighing up to 80 tons, the entire timeline of the pyramid's construction remains broken. In 2013, archaeologists at Wadi el-Jarf uncovered a cache of papyrus fragments dating to year 26 of Pharaoh Khufu's reign. It is known as the Diary of Merer. This document is an operational logbook tracking the transport of limestone from the Tura quarries across the Nile to Giza. It is a record of movement of middle manager. This ledger establishes a verifiable chronology, pinpointing exactly when massive shipments of heavy stone arrived at the Giza harbor. The diary establishes Merer's role as a supply chain manager. The foundation of the Great Pyramid was built on rigorous boat movement schedules and precise logistics. While the diary maps external logistics, mapping the internal architecture requires looking inside the stone. In 2017, the Scam Pyramids project began doing exactly that. Researchers used muon tomography, a technique where cosmic rays passing through the pyramid are measured by detectors to map hidden density variations and internal cavities. This scan revealed massive thermal and density anomalies inside the structure that traditional archaeology could not detect. The largest anomaly is a massive, previously unknown void situated directly above the Grand Gallery. Particle physics has successfully mapped the internal spatial data that remained hidden for 4 millennia. This is where we connect the dots. The public interprets the void as a secret chamber. By connecting the logistical chronology of Merer's logs, specifically the period of intense granite transportation, to the void's location, a pragmatic engineering thesis emerges. The void isn't necessarily a burial chamber. The leading evidence-aware interpretation connects it as a functional element, perhaps space for a counterweight lifting system or a crucial internal ramp structure used to hoist the massive granite stones for the king's chamber exactly when Merer's logs say they arrived. This solves the bottleneck. The void is a purely functional mechanical feature, the internal engine of the pyramid's construction. These massive granite blocks were hoisted to their destination in the king's chamber. The unadorned stone walls and the heavy, stark sarcophagus suggest raw functionality over ornate decoration. Once the void served its mechanical purpose for lifting these specific chamber stones, it was sealed away and rendered invisible to history. The Great Pyramid is the fossilized casing of an ancient mechanical lifting machine. Merer's mundane ledger supplied the chronological timeline, and modern muon radiography supplied the required physics. The engineering marvels of the ancient world are demystified when we understand that success was the result of the rigorous execution of overlooked logistical details.